Welcome to Agentics New Zealand for a special session. It's lunchtime. We've got Ocean, who's dialed in, especially from New York today, to talk to us about Lion AGI and Khive and what all that's about. So the floor is yours, my friend.
Can I share my screen?
Let me give you presenter rights if I don't already. You should be able to. There you go.
All right. Oh, okay, great. So, hi everyone. My name is Ocean, and then I've been working on this framework called Lion AGI for about 2-3 years, and I am a co-founder of the Agentics Foundation. Basically, in 2024, we are a very enthusiastic community. And then in 2025, we formed the nonprofit, and then I've been doing a lot of open source research and development. So let me walk you through a little bit of what is Lion AGI. Lion AGI, well, Lion AGI is a framework for building intelligent systems in an automated manner. So I have considered various situations in how a agentic workflow would do, and then provided a lot of primitives to do those. And more recently, I've been starting to use those primitives myself to kind of deliver how you actually do it in the end process. So for example, we used to do a structured output via response format, and then you put a pydantic model back. However, you're not able to kind of react to it when this is happening. Let's say you have an agent run. It's doing its action call. It's reading its files, editing, or doing web search, and finally give you a finding. But what if there are certain information or things that it found interesting during the middle? And then let's say it reads some file, and then immediately we want some kind of research to go along with it. And that's when the reactive pattern becomes powerful. You can have one agent run that goes do its own thing, have 5 findings out, but then other processes can handle it. This is very different from sub-agent, and I'll show you how. The model is the engine. Yeah. So here is the reactive loop. When agent is doing its own reasoning and finding, Lion AGI system will be able to capture those as signal. And then when the session itself is being observed, so the observation can be typed, can be based on the agent's metadata. So for example, in this loop, we got the agent emitting findings and questions as it goes. And we have a session hook bus that is able to dispatch and handle all of those situations. And then via the observe and finding, maybe a certain condition is met. Let's say it's very novel, and then need to spawn a new different agent or feedback to a same agent. This is not very laid out, very nicely opus. I'll skip this one. Oh yeah, the observer pattern. I introduced a tiny DSL into it. It is very convenient to observe so for example, by finding, this is when a model emits a structured output during its thinking. That is a type that you can do for. And then you can also check by a specific field. Let's say you allow the model to emit up to 5 different type of thing. That is optional. And you can check the value by using a query pattern of the internal value. So let's say You ask it to do to search, and you check for the input. When you detect the word, let's say, dog, you will do something about it. But when you detect cat, you might do something else. And this system allows you to real-time react to those. All right, let me just go a little bit quicker. This is the second portion of the direction of Lion AGI, which is runtime-composed agent. I define agent as a configuration with runtime state, but an agent itself, it's only meaningful during the runtime. So this brings a question about the configuration of agents. Right now, most of the agents are pre-written in a markdown file. However, I can't help but believe that the context-aware composition of different sub-agents will be more effective than a preset of agents to do work. Of course, that really depends on the type of work. So a role in this sense would be a behavior pattern of what exactly we want the agents to do. And a mode is how we want them to think. So let's say you have an implementer and you have a slow and deliberate mode, and you have an implementer versus a fast mode. Those can be applied in different situations while not configuring two different implementer. And that mechanism of how to choose those, how to combine those, is where I think orchestration can be really interesting. Agent spec compose, yes. Yeah, so an agent in Lion AGI can actually be other harness as well. Lion AGI can orchestrate things like Claude Code, like Codex, Gemini code. So it doesn't have to use Lion AGI's internal harness for coding. Yep, and here are some of the patterns that are easily doable in Lion AGI. I will put out more demos, examples around this. These are pretty new. All right, so I think this is about it. Any questions?
So, Ocean, you'd also mentioned in some other posts of yours that this framework is not purely around use of LLMs. You know, when you can compose different kinds of processes in this framework, right?
Mm-hmm. That is correct. So in operation, let's see if I have those. All right, I'll stop sharing my screen for a sec and then find some other things to share. So an operation in Lion AGI is an arbitrary thing. Okay, I found it. Oh, all right.
There it is.
So here's a flow DAG where in this case, yes, all the nodes are agent. This is when I'm using leaf flow, the CLI for it. I give the flow a task. The orchestrator here will be able to decompose it and then make it into a DAG. And then they just run according to their dependency, according to the relationship. And eventually there is a synthesis node. Note that every operation in here is arbitrary. It doesn't have to be a LM. It can be a flow of LM. It can be another DAG of itself. The Lion AGI system only cares about the computation around this in the dependency. It execute those, keep all the states, record them, and then provide the same observability and permission control.
Okay. So then, that seems to be pretty unique. What else? Like looking at what other orchestration frameworks there might be out there. There are a bunch. What does this do that those don't? Like, what is sort of the guiding principles around this? And
Yeah, so I'm just gonna share another thing. I should just share the screen. All right, so here is Lion Studio. Here's Lion Studio. This is a front end for observing everything, and here is kind of the fundamental philosophy behind, which is radical observability, and then be able to control everything. So, for example, you have a lot of agents running, and you have them run in different patterns in different projects simultaneously. It is very difficult to know the entire picture of what's exactly going on. For example, let's say you have a very complicated orchestration like this. This is a P at Lion Studio. I wrapped this into an agent scale that your cloud can just use. A play is a DAG, like I showed you before. It is templated with some different kind of configuration on how the orchestration should go. And a show is a DAG of DAG. The orchestrator will be able to come up with all of this plays carried out. I think this one particular probably ran for a couple of days. It ran through 16 plays, and then each play is about maybe 20 agents, 15 agents that go in according to their own logic, and I just leave it alone. Oh, here's the sequence of it, and this one looks pretty linear.
Yep.
And let me try to find the one that's a little bit more interesting. Research. Okay. I'm not sure why it's not showing the rest. Anyway, so that looks messy. Let me find a different one. Test coverage? No. Let me find a different one. Reviewer session. Anyway, this front end is still a working process. I was able to find a few nice looking ones, but not sure about today.
I remember you saying in the past that your guiding principles around this and your thinking around your orchestration thinking was that you wanted it to be explainable. You wanted to really to be able to go in and show the whole trail to verify it. So I guess that seems to be sort of the unique selling point of this framework. Did you want to talk a little bit more about your thinking there?
Yes, the governance part is where I'm heading towards next. The ability to, so related to the emission model that I showed earlier, when I observe a model's internal process, and then when they emit a signal and I process it, that I grant it as a capability for the model within the system. And the capability control is really what sets Lion AGI apart with other frameworks. The control is set at a very granular level at the structured output type. If the structured output is not being pre-configured, granted, etc., the system will just simply ignore that.
Yep.
It's not possible for a model to do things that was not allowed in the system, just period. And it's really difficult to explain.
Do you want to give us an example? Maybe we could, you could walk us through like just a simple demo. Like what does using the system day to day look like if you wanted to kick off a task?
Yeah, sure. To start a task, I need to show a different window. presenting something else. All right. So to use Lion AGI in a day-to-day, I usually go for command line and then use that as a monitor. For example, I have one project here. I'll say show that is a skill that is in Lion AGI marketplace. And I say discover. Let's see which project this is in. Okay. Discover the issues in Lion AGI front end. Compare with other agentic systems. And position Lion AGI for seed round, for example.
So what is show doing?
The show is the most grand form of orchestration in the setting. It decomposes into multiple different flows, and then run those flow in parallel work tree. Well, it really depends on the dependency.
Yeah.
So, this 4.8 is very slow. But a show like I showed earlier. Let me go back to that. How can I share both of those at the same time?
Both at the same time. You need to share your screen, not your window.
Okay. Entire screen. This one. Yes. So let's go back to a show. So for example, when this guy launches the command line, and then we won't be able to see the running now, and then go to see the actual activity in real time in the runs. And let's check a show as before. Yeah, so it is kind of just planning this graph right now. As it plans out.
So this is the live data that's going on.
This is real data. This was the old one. It hasn't launched yet. It is still doing some discovery itself and making the plan.
Yeah. Okay.
So each DAG, my philosophy is you don't tell them the script. You tell them your intent and then what you want delivered. The orchestration itself happens within the play, so that the main guy that you chat with will have its own context more preserved. It will be able to orchestrate through this potentially hundreds of agents orchestration within one context window, because most of the planning were done by the internal orchestrator. And that has been very fun if you want to bootstrap an entire project via a show. It goes very well. Or if you have 100, 200 issues, I sometimes let them run overnight, and I say, please open all of them as appropriate PR. I'll come review in the morning.
Hey, Beden, you got a question?
Yeah, I'm a bit lost with what is this. So I just pasted in that discovered issues, whatever, in ChatGPT. I got an answer 3 seconds later. What does your system do that ChatGPT doesn't?
It is the recursiveness of correction and the self-steering functionality of more complicated process. So when you ask ChatGPT to discover issue of a repo, sure. So when you ask ChatGPT to discover of a repo, that is a single run agent process. It keeps on going through the repo and find things itself. However, here, the structure of how this is closer to the dynamic workflow within Claude Code. If you have tried that, it will be able to come up with phases and then run those each phase depending on their own dependency.
Yeah.
So this is closer to that in the sense we have a broader angle.
So it's like you say, it's decomposing your request into all sorts of a structured approach, and then assigning different agent types to do various types of work, and to break it down in a structured way.
Yeah, absolutely.
Project plan.
Yeah, I was just reading through the repo, actually, GitHub repo, and the first line, it says like a multi-agent workflow framework, and I think that is completely underselling what you've done here, because again, it's got the provider abstraction, it's got structured output operations, it's got the code and agent tooling inside, persistent states, it's got schedule, it's got reusable playbooks. Like, it's completely way more than just like a multi-agent workflow. So I just want to say thank you, because I've just been reading through the GitHub repo on that, and I can really see how this could be, obviously before dynamic workflows, like this is really useful as a runtime system to use on the day-to-day.
Yeah, thank you. And then I do want to show more of what the system can offer. So I also have this plugin system where you're able to kind of observe everything that you are granting your agents to use. I find the markdown to be very awkward in terms of the visibility and management, but maybe I'm just not using it right. And then there's some skills within LionAGI as well. And as we know, a skill is just you point to a file and then print the file information out. I'm mentioning all of this is the entire process is heavily monitored and controlled, because I don't really trust this kind of non-deterministic processes.
Yeah.
And by observing every state and input-output, I'm hoping to replay or even in a way backtest certain process such that you can optimize the process. If you're not able to observe what's happening in the middle or understand why that even is going on or how to control it, then as the agentic process run longer and longer, the output might be diverging from what you want. Now let's see whether or not it actually asks any guys to do stuff. Why is it so slow? I'll use a lower effort. Come on. No, I'll do all myself.
So I got a question. So around tool calling, do you have anything that can sort of ensure compliance, that tool calling is done to a specified method or approach?
This relates to, so first I want to show that it's difficult to answer this because the customization room is so large. What I'm doing is more using a hook method, like before the action call, after the action call.
Right.
So for example, during a branch process running, I'll check whether or not those particular resources are even granted. If those resources are not granted, they won't even appear in the agent's prompts.
Oh, yeah.
And then I think it's about, would you allow the agent the allowable space of that is the kind of the point, a typed namespace for the agent during the process, what's allowed and what's not allowed. If you defined it already, then things don't allow just can't happen.
Okay. So you can sort of have a defined set of rules.
Yes, using permission system as well.
Nice.
There are a lot of mechanisms for doing this, such as the reactive system I showed you before. You can that is detect a signal of the tool calling, or you can do it as a pre-processor before the tool calling. And all of these layers, I'm hoping they to serve different functionalities. So let's say the pre-processing of a tool calling, that can be a very strict policy engine check. So you identify this process, and then you identify its privileges. And as the action calling, you can do a, let's say, Rego check. So Rego is the policy engine by Microsoft, commonly used in legal tech. And you can literally have legal tech-like rules for each of your agent. And those will be faithfully checked before every action call. And that is what I'm introducing next to the system.
Nice. Very cool.
Yeah, any other questions? Sorry if I'm losing everybody.
No, I think you've kept it pretty steady.
Yeah, what did you use for memory? So I saw you were using a memory system. What is your memory system here?
Yeah, the memory system is a separate project called Khive. Oh, I completely forgot to discuss that today. Khive is a graph runtime in Rust. Khive is a graph runtime in Rust. It provides a lot of tooling. Yes, it provides a lot of tooling for the agents, such as the knowledge graph itself, get things done methodologies for tasks tracking, memory, and then a brain, which is some kind of feedback mechanism to the retrieval, and then communication among multi-agents, and scheduling and knowledge. Knowledge is the long-term corpus of or canonical data that you serve as reference. And there are various different retrieval methodologies to do this. So the knowledge is done by ANN for a larger indexing, and then the memory, communication, and such, those are indexed in HNSW, supports multi-embedding retrieval. So currently the default is two embedding models, one for paraphrasing and then one for a quick, efficient embedding check. And then I use reciprocal fusion to get those candidates and then re-rank them. The embedding model underneath, that is the cool part I want to show, is the engine that I made myself, an inference engine called Lattice. Lattice inference engine is a pretty fast pure Rust engine that I made just for Khive. It is about twice the speed of Llama, and I have been working a lot on very tiny small models such as Quant 0.8 billion parameter. Goes back to the brain in the Khive for that feedback mechanism, for example. We can use a very tiny model as a re-ranker for that. And then for the brain itself, when the feedback, that will be a tiny LoRa adapter. And that tiny LoRa adapter can be trained or tuned in real time as the system feedback to that profile. Yeah, Lattice is pretty cool. This is the most fun project I've done because it's incredibly complicated. It feels proud. It feels proud when you come up with an engine and then you see, oh, twice the speed of Llama. Am I hallucinating? And then you go a couple days, do all the benchmarking you can, and just like, okay, I'm not.
Is there anything you can show to see Lattice in action?
Oh yeah, sure. Let me spin up Lattice. Lattice.
So this is just running on your Mac.
Yes, not a good practice. That is why I'm switching to the Daytona sandboxing nowadays, trying to do that. Oh yeah, for Lion AGI today, I've been doing HWE benching, and then that's why I introduced Daytona. So session start. We are doing demo. Show us Lattice and how cool we are. In Lattice, I support mostly embedding models right now. The BGE, but I also have included support for the LLM as well. I don't know why it's not in the docs. I need to check. Inference, SRC, model. Yeah, I support Quant 3.5, BERT models, and then Quant 3.6 as well. I think as well. I've included a lot of attention mechanism. And another point of Lattice is I want models to self-discover architecture for different models and trying to make it more composable. A lot of optimization around Lattice is done by itself via a show, let's say, overnight. It comes up with different hypotheses, test them out through a benchmark-oriented development. And then everything got opened up as issues, and then I come check with it back and forth, etc.
Yep.
Yeah, so what are you doing?
So presumably you used Lion to create Lattice?
Yeah, most of the development is just kind of done like this. My development process is I would chat with, I do want to show, or do want to see what it come up with. Generated task. So Quant 3.5 generate, and then in one sentence, what makes pure Rust inference engine special? And that is inferenced by Rust, loaded in 18 seconds, and has a thinking process. Specifically. Oh well. Let me ask you to please inference the Quant 3.5 0.8 billion model and show us the speed comparison for a 1000 token context and 100 token response. I'm sorry, Chris?
No, I didn't have anything. I'm just enjoying the show. There was earlier, like you kicked off that process with going back to the thing you started earlier. I wondered, is that still going, or did that produce some outcomes?
Oh, that previous one? Let's see. Let's see. I have to find it. Project. Oh, I stopped it. I was like, come on, run a real one. It leaves your eye. I should run one just by myself, to be honest. If you run lead playlist, and then I have a bunch of stuff. Architecture discovery. Okay, let me run that. Now you're useless. So if you run lead play discovery architecture, and I would say, please look into Khive and Lion AGI. See how can Khive tooling be applied, and how should Lion AGI architecture be how should Lion AGI evolve into? Should we add knowledge substrate for the agent? And then I'll say max operation be 50. I'll do bypass, and I'll do a ting mode. Khive Lion discovery, and I'll do it verbose.
Spelling. Discovery. Spelled wrong.
Yeah.
Doesn't
It
matter.
doesn't matter. It
Okay.
doesn't matter. Okay, right now, so it is kind of running. I'm not sure what's going on. This is using my local development. Am I doing something wrong here? Yeah, this is using my local development package, which is not stable right now. So I'll have to debug that. But this is how you invoke a play, and then going back to the DAG I showed.
Okay.
And typically, it will be Cloud doing this, not me.
Sure.
All right, what are you doing? it just go about and do benchmarking itself now. All right.
Oh, it's built the bench. It's built the benchmark. Okay.
Benchmark verifying. I just want to see, let our model say Paris. That was the most exciting time I had with this. When you start tuning a model from, I kind of hand-wrote the tokenizer and everything. The model keep on giving nonsense. It was just, I was just checking tokens by number. And then all of a sudden, when you say the capital of France, and then it says Paris, that was very exciting to me.
So you've built a runtime engine essentially for running models, and your goal was to make it like what was your goal going into that? Was it that to make it run more efficiently, or what was your thinking?
One is to not depend on ONNX. ONNX is based on C++ runtime, and then that make the binary size very bloated.
Right.
This is more for embedded inferencing on your edge devices from my view, and it's specially designed for tiny models to do just one specific thing. And I am introducing LoRa tuning to this.
Right. So this is a Rust-based system, right?
Yeah, this is Rust. This goes back to the agent composition I was mentioning. The kind of tiny model will serve a big part in the customization of those engine, and I hope those runtime customization will have a bigger effect. But this is a very big research topic because too many variables inside.
Yeah, Chris.
Hey, Ocean, just a quick question, just maybe about the future, because I was just, again, been quiet because I've been reading through the code base on Khive, and I can see using SQLite there, and it looks like there's only one connection, write connection to SQLite, but then you've got up to like 8 reads. Now, obviously, doing this local where you might have several hundred agents or several thousands reads, that might be fine. But what's the future around the actual database layer there? Would it be multiple reads? Were you going to hit the wow effect on SQLite there as well, or are you going to move that into like a Postgres or something else? Yeah, so just quick question on that.
So in Khive, the storage is agnostic in a way. Yep. I defined it just as a trait or capability. Wait, where am I? A trait or capability. So let's take a look at this storage. In the SQL, this is just the trait I needed to be. So currently, I only have one, but I will be able to just introduce a KhiveDB Postgres, and then be able to plug that into the application service layer, which are the pack communication, knowledge graph, etc. They are bundled by the pack architecture, all the features inside, and each pack, during the runtime, you can pick different backend.
Yeah, absolutely. And then you can start doing connection pooling on the SQL connection to Postgres. So yeah, awesome. Thank you.
Yeah, so your knowledge can be in one backend, that like a very large corpus of your internal, and then the agent's memory can be another one, and etc. So the communication might be in a different one for remote agent to talk to each other. I've introduced a lot of interesting things here. Need to discover them. So, for example, let me go back to the storage. I've introduced sparse storage capability. I've introduced SQL. The entities and nodes, they are internal concepts within the Khive. And I have a graph store, which you can curate by graph relationship. Events, that is the auditing of the entire system. Every single event ever happened will be audited and capped. That has a few implications on how you govern the agent behavior from the tooling side. And I have a vector store, sparse vector store, and a text store. All of those can be extended via the whichever backend you prefer.
Got a question in the chat. What are the most useful use cases for this type of orchestration system?
It is more deterministic in a way, explainable, repeatable workflows at a large scale. That is the most useful cases, I would say. So if you have enterprise workflow that are complicated but highly repetitive, you can tune our workflow for that, for every single step, pick the cheapest correct model for that particular step, and hopefully you can optimize the process to be just as good, let's say running everything Opus, but maybe at 1% of the cost.
Right. So you're putting sort of all of that, essentially that IP and that reliance into the how you've structured the workflow, as opposed to relying on the model to get you an outcome, which might be different when the next version of the model is released, or they change the model and we get a different outcome.
That has been somewhat of an issue for me as well when using Claude Code. When 4.8 came out, my previous harness was more optimized for 4.6, and I have to change my prompting, change my guidance, etc. It is fine for my individual developer working, but if you have like an enterprise experiences, that wouldn't be as nice, and very expensive, to be honest, if you use Opus for everything.
Okay. Kennedy, go.
Yeah, I'm just wondering, are you using this through the API with Anthropic? Because I've heard that if you're using the API directly, sometimes the changes in the model are less significant because it's not running through Claude Code's harness.
Right now, over here, what I'm running, this is Claude Code.
Sweet. Sorry, I'm on my cell phone, so I couldn't actually see what was going on. Because I've been having to move away from using Claude Code, especially now that they are taking away headless invocation and taking that out of the subscription limits.
Yeah. So on that, yes, I support both the API as well as just the headless itself. That is an issue. Yeah. Not sure how to make the headless work after that change.
Yeah.
But I can support Codex and then Gemini code and everything else, and open code.
So I was going to ask around obviously running this locally, which you are, and you're on your computer now. It's doing quite a few, what I would say, heavy CPU cycles on different things. So, which anyone who's used the dynamic workflows in Claude Code, obviously that all goes off externally into their infrastructure to be able to do that. But we're effectively putting it here in your infrastructure on your local laptop or server or whatever you're using. How you do find your PC handles that? Like, and do you mind me asking what type it is? I think is that an M2? I think in the stats that you've got for your laptop. So how are you finding this running with, say, 1,000 agents running on your machine and doing using the CPU, the SQL, the Khive database as well? Yeah.
For that large of amount of agents, I've actually not done like 1,000 at a time, to be honest. And it really depends. So if I run a Lion AGI agent, that probably is pretty doable. Let's say even 50 or 100, because that does not have as much overhead. But if I'm running Claude Code, I think the max I can do is 50. 50 to 80 that I found my computer to be handling okay. This is a MacBook M2 Max. Oh, the stats are not that interesting. Wait, so we're slower? This is why I need to benchmark it. Can't trust it.
Yeah, funny. So we've got some stats back from Lattice, and unfortunately, it didn't stack up against Ollama.
Yeah, I think the benchmarking, we're trying to bench the same thing, bench a different thing. It was not the end-to-end.
Are you doing that locally on your machine though, while also running Hangouts?
Hangouts and doing some other stuff too.
Well, and Docker and Codex and
It's all good. Hey, it's pretty impressive stuff. We'll just sort of start to bring it to an end. There was just a good follow-up there from Vin on when we were talking about how we're optimizing the system for to be able to cater to changes in model performance over time. So then how are you optimizing your system for that? And so how do we benchmark against that, so we can sort of sense what's changing from model to model and how your system is catering for those changes?
Right now, I am doing SWE benching for those, and I will do very similar kind of benchmarking system for example. Let me show.
We bench for Lion AGI.
Yeah.
Okay.
Benchmark for Lion AGI to. Let me find it. I can totally find it. Benchmark. All right, so let's bring over Lion AGI. So find me the benchmark we did, probably as a benchmark we did on Daytona, SWE Mini, and stuff probably in a PR. Maybe it's easier for me to find the PR.
This is a bake-off between a human meat brain and a AI brain. Who's going to get there first?
No, probably merged it already. Let me find it. Benchmarking, orchestration, suits, SWE bench. Oh, sandbox runner.
Benchmark workers on PR 1245.
Yeah, this runs the entire process in a Daytona sandbox and get diff back. So I guess if you run 100 of this, it's fine too. if you have that level of sandboxing limit.
Interesting. Cool. Well, so yeah, you've thought about it. That's awesome. Hey, dude. Well, geez, that's been an epic session, and that's sort of, I'm kind of reeling from all of this, mate. There's so much to take in there, and I'll be unpacking this for days to come. So what's next for you with this, mate? What is the next step? Are you bringing this to market? Are you running this as a service? Is there an open source story? Like, what does this look like for you going forward?
Yeah, for Khive, I am trying to angle it as a infra-like product to the market. So to begin with, it will be a MCP based, so that your agent can have those storage graph as tooling. The angling is that I use Lion AGI as the orchestration framework and distribution channel, and use Khive as the underlying state keeping mechanism, and then reinforcement, optimization, those nice things. And that is currently the idea. I do want to introduce governance into my product offerings. However, I'm looking for angling around those as well. I do feel that current market will hit a very big adverse event before people are paying big attention to agent governance. But I hope the adverse event doesn't really happen, but we'll see.
Yeah, I hear you, man. Well, hopefully your stuff is well positioned to solve that problem if and when it arises. It's been awesome, dude. Well, thank you very much. And for those on the call, we do have another session tonight at 7 o'clock. If you're keen, should be a good one. If you haven't seen Blair, heard from Blair before, he's pretty impressive. So hopefully we'll see you there. And thanks again, Ocean. And yeah, you're welcome to come and hang out with us anytime.
All right. Yeah, let me know.
Cheers, man.
Thanks.
Thanks.
Thank you, Ocean.
Bye.
Thank you, Chris.
Cheers. See ya.